Hey guys, welcome to the error analysis video on rational equations. I included some inspirational quotes here for you guys. I know it's getting towards the end of the semester and you're all feeling run down and you're tired, but this is just a reminder to keep pushing through, especially if you're really struggling with this particular content. Just keep practicing. Just like the first little clip says, it's not about being the best always. It's just about being better than what you did yesterday and the problem before that and the problem before that. Dr. Maya Angelou always said it best: do the best you can until you know better. And now, when you know better, do better. I believe in you guys. Take this opportunity to reevaluate how you approach rational equations, and I hope that walking through the steps with me can really give you guys a leg up and help you understand the process a little bit easier. So let's go ahead and take a look at our first rational equation. When we're adding or subtracting with this equation, we care mostly about the denominators and whether I have common denominators or not. The left side, we do not. And then we have this other trinomial that isn't factored, but let's go ahead and take a look at that first. And we're just gonna curious what that is going to turn into. So 1x squared times 3 is going to give us 3, and it needs to multiply to give us negative 4. So this is going to be a negative 3 and a negative 1, which, coincidentally enough, is the same thing as our denominators on the left side. So x plus 3 and x, sorry, that was a minus, wasn't it? Let's try that again. Be careful with your negatives. X minus 3 and x minus 1. So now we can clearly see that our LCD for all the denominators is going to be a combination of that x minus 1, x minus 3, where x cannot be positive 1 or positive 3. Set each of those factors equal to 0 and solve. That's how we get those. So what I can do is multiply through by the LCD. I'm going to do that in red here. So I'm going to multiply this whole thing by the LCD, and I'm going to multiply it, the first one, the second one, and the third one. So I'm going to go ahead and write the LCD. It's a little large. I might run out of room. Times that 2x. I'm going to go back and rewrite the denominators here in just a second. I am going to run out of room. We're just going to move this real quick. Okay, our LCD x minus 1, x minus 3, times the 1 in that numerator, and that's going to be equal to x minus 1, x minus 3, times the 2 in that numerator, all divided by this denominator was x minus 1, x minus 3, x minus 3, x minus 1. Now that we've multiplied through by the LCD, it's going to make a lot more sense for us to go through and cancel and see what is going on. So in this first fraction, we can clearly see that x minus 1s are going to cancel. In the second one here, I have the x minus 3s that are going to cancel. And then in the last one, both of them are going to cancel. So now all of our denominators have gone away, and we are left with I'll write it out for us again. 2x times x minus 3 in the first numerator, plus 1 times x minus 1 is just going to be the x minus 1. And that's going to be equal to, we were left with the 2 in that numerator. Distribute out. 2x squared minus 6x plus x minus 1 is equal to 2. I have the square term here, so what that indicates to me is I'm probably going to have to factor. So not only am I going to combine like terms, 2x squared minus 5x minus 1 equals 2, I need to move everything to the left side, or one side. So I'm going to subtract 2 on this side. 2x squared minus 5x minus 3 is equal to 0. There's nothing more that I can factor out with a GCF. So we're going to go ahead and do our x method. 2 times negative 3 is negative 6, and it needs to add to be a negative 5. That's going to give us our negative 6 and positive 1. Then we're going to do the shortcut method where we divide by a. So now this is going to break down into x. This first one, negative 6 divided by 2 is negative 3. And then this fraction, remember, if we put it back in our factor form, it's going to be 2x plus 1. You can set it equal to x and then solve, but you keep the sign the same. And now we're just going to go through and solve each of those. So x is equal to positive 3 or negative 1/2. We still need to go back up and check our restrictions. Now here we have a problem because x cannot equal 1 or positive 3. So the solution here is not a valid solution, and x equals negative 1/2 is our solution. A little bit lengthy. Hopefully your handwriting is a lot neater than mine. Go back through and pause the video as you need it, and ask questions as you need to as well. Number 7. Now this one's going to be a little bit nicer because I can see here that my denominators on the right side are already equal. So I can go ahead and combine the right side. 5 over 1 is going to be equal to 2 minus k over k minus 1. Now since I have everything over one denominator and an equal sign in between, I can do cross multiplication, or the butterfly method as you might know it. So I'm going to 5 k minus 1 is equal to 2 minus k, because it would just be multiplied by 1. 5k, ooh, it's looking rough. Let's try that again. 5k minus 5, because we distributed, is equal to 2 minus k. We like keeping k positive, so I'm going to add k to both sides. That's a plus. Give us some more room to work with. 6k minus 5 is equal to 2. Add 5. 6k is equal to 7. Divide by 6, divide by 6. K is equal to 7, 6. But we still need to make sure and check our restrictions. So we're going to scroll back up and look at our problem. Here, I would have a denominator of 1 under the 5. So there's no variable to restrict, so that one's okay. And then this k minus 1 as a factor, k cannot be positive 1. So our solution here of 7/6 is a valid solution. Sorry. We're good to go. All right. Some of you feel the dreaded word problem. It is okay. Michelle and Brandon work as computer technicians, which mean they build computers. Brandon can build a laptop in 15 hours. Working together, it takes them 5 hours to build a laptop, is the impression. How long would it have taken Michelle working alone? So the format we're going to use here is time together over time alone. Time together over time alone equals one job. The one is always constant. So let's look at the two of these guys together. Michelle and Brandon work as computer technicians. Which means they build computers. Brandon can build a laptop in 15 hours. So that is by himself. So his time alone is 15 hours. Working together, it takes them 5 hours. So both time togethers are going to be 5. And now the question is, how long would it have taken Michelle to do it by herself? So her time alone is going to be X. Now, we can approach this problem like we did question number 6. I'm going to find the LCD, which if I look at both denominators, I have an X and I have a 15. So the only thing that they're going to have in common is if I multiply them together and get 15x, because our 1 over 1 doesn't have a variable to restrict. So our LCD is going to be 15x, where x cannot be 0, which if you think about it makes sense. Michelle is not going to just not build the laptop, right? She needs to earn a living. So we're going to go ahead and multiply through by the LCD to all three here. $15x. I'm just going to go ahead and write it out. 15x times 1. This was 5, 5. And then everything was over. We had x, 15, and 1. Now we can go through and simplify the things that cancel out. So in our first one, the x's simplify out. The next one, the 15 simplify out. And the last piece on the right, none of these cancel out. So now we can go through and look at our numerators and see what we have here. So 15 times 5, is going to give us that 75 plus x times 5 is 5x is equal to 15x. Now we want to get x by itself, so I'm going to go ahead and subtract 5x over. Give us some more working room here. 75 is equal to 10x, divide by 10, divide by 10, and working alone, Michelle, it would take her 7.5 hours. Now we do want to recheck our restrictions. Yep, she didn't work no hours, so 7.5 is a valid solution and the answer to our word problem. Take some time to go over this. Please work on the extra problems. Practice, practice, practice is the best way to get better at these. The answers are provided for you. If you need help with any of these, please come see me, Ms. Henchman, or Ms. Jennings during either lunch or tutoring. We would love to help you guys get better at these. Happy solving.